Hello, welcome to the MicroCART architecture explanation video. The goal of this video is that you should be able to watch hopefully a 10 to 15 minute video and then walk away knowing the very basics of the different parts of the MicroCART system. Um, I am not going to go through everything that is in these slides. I'm going to let you pause. I hope that I have put enough information on the slides that should you pause, you can get a lot more information than what I'm going to say. Um, if I go through all the slides, this is going to be a long video, and I don't want to do that to you. So what I'm going to talk about is just the rough overview of the different components of the project. We'll go into a little bit of detail towards the end, but we're going to go pretty fast here. So buckle up. What is MicroCART? MicroCART is a senior design project that's been going for about 20 years. We build and fly embedded systems that are either helicopters or quadcopters, and then we help support classes and researchers that use these systems. Um, a good example of that is the Computer E488 MP4 lab. Um, and my team made this one on the far right, so that's pretty cool. What are the different pieces of the puzzle here? So first of all, like administrative, most of the development for this project is done on a VirtualBox VM, and that's either available on the wiki or the team box. And yeah, so the big pieces of the puzzle here is the ground station, which is what you use to actually fly the drones. And then the drones, the Crazy Fly and the FlyPy are communicated with through the Crazy Radio right now. And the custom quadcopter is just a direct TCP connection. There's these trackers. The OptiTrack system is all the big motion capture cameras in the 3050 lab. And then there's also the Crazy Fly test stand, which can give you feedback about how the Crazy Fly or the FlyPy is moving around. Um, yeah, and so the different quadcopters that we have available here, there's the custom quadcopter that's all FPGA based, made over the course of several years. Super well built up, awesome, but very large, very intimidating. So you wouldn't really want to use it for a Computer E488 lab. Then there's the Crazy Fly, which is very small and rather friendly, and you would want to use for the Computer E488 lab. It's open source hardware, open source software. And yeah, it's pretty awesome. So there's some modifications that we've made to the software of it and to the MicroCART ground station stuff to support its integration. The FlyPy is the drone that my team has made. The intention is that it would be a flying Raspberry Pi controlling a drone. That part doesn't work. So right now it's a Crazy Fly that just has its motor outputs mapped to the ESC that's on our board. So yeah, it's pretty powerful, pretty fun to fly, and it actually flies, so that's pretty cool. Um, Now, all of this works off of control algorithms. So control algorithms are basically the things running in the embedded system that help it actually know how to fly. So what is a PID controller? You might be asking if you don't know what that is. So a PID controller is basically just a type of control system that tries to control a process variable by like you have a set point and then you have a output. And basically there is this idea of error, which is the difference between the set point and the output. Um, and a PID controller tries to minimize that error. And it does that through a couple different methods. There's the proportional term that basically it will actuate the process proportional to that error. So let's say you have a drone that's flying and you have a set point here. A proportional controller would basically start, you'd fly up, and then you'd be actuating less and less as you get closer to it. Then you might overshoot, and then you'd be, then it would start pulling you back down, and it would kind of start oscillating like this. That would be a good example of a proportional controller. It may not oscillate, but some systems would. A derivative controller would then, or the derivative term in the PID controller would then try to damp the oscillations. So if you had that P controller with like a high derivative term, you might see it instead of oscillating quite as much, you would settle to the set point much faster. Now, if it were to settle to the set point and or settle just to like a steady error from the set point, like say your set point turns up here and you go like that, or your set point is going on here and it's just steadily off, but it still responds, then that's where you'd have an I term that would over time remove that steady state error. That's what it's for. Um, and then you can also go further with this. You can have a PID controller, the output of the PID controller be the set point for another PID controller. And so that's actually the way the CrazyFly and the custom quadcopter work for PID controllers. You have a attitude controller feeding into a rate controller. And yeah, that's about as deep as we're going to go on that. There's a third type of controller. There's these full state feedback controllers. And specifically the thing on the custom quadcopter that you might run into with these is the LQR controller. A full state feedback controller basically takes the full state of the system and feeds it into a dot product with a K vector or K matrix, depending on how many actuations you have. And then that dot products with it, and then that sends out your actuations to go into it the next step. This is a much more complicated, much more advanced type of controller. And basically, I would say you probably would want to take 475, 476, the electrical engineering classes, before you start messing with this, or you might just want to go pretty deep on how full state feedback controllers work. LQR controller basically tries to optimize the feedbacks in order to penalize different actuations differently, and they're pretty cool. So then the ground station, we can go into a little bit more detail with that now. Feel free to pause the slide though. And if you want more information about how it works, you can watch the ground station explanation video. That'll give you like a half-hour overview of how all this stuff works. The ground station, basically the main MicroCART ground station has a user interface that calls these front-end functions that are connected over a TCP connection to the back end. The back end is what connects all the different components of things together. It lets the front end talk to the drone. It lets the tracker that tracks the drone tell the drone where it is, and it will route to the CrazyFly as well, communicate with the CrazyFly test stand over the Crazy Radio to the CrazyFly, and you can also track multiple drones. The CrazyFly adapter basically will translate backend commands from the default packet structure that would work perfectly fine with a custom quadcopter into a command that the CrazyFly can understand. Currently, the CrazyFly adapter basically lets stuff just pass right through, and the CrazyFly ground station is actually what is doing most of the talking. Those should probably be combined, and they should probably use the open source CFlib software. In the spirit of those probably should have been combined, we also made a custom CrazyFly only, basically, ground station called MicroCART, that basically just tests how stable is the connection when you don't have the rest of this infrastructure in there and you just have CFlib communicating with the CrazyFly, and it works a lot better. So thoughts from that should basically be implemented into this CrazyFly ground station. And yeah, okay, then the user interfaces. It's basically what I just said. There's the MicroCART user interface and there's the MicroCART user interface. MicroCART was made to understand why MicroCART it doesn't really work, and there are pieces of it that should be slotted into the main MicroCART infrastructure. If you want more information about how this works, you should either watch the GUI explanation video or you should watch the ground station explanation video. Those both will give you more information about how these work. The test stands, basically, there are test stands that are made to test the custom quadcopter, the CrazyFly, and the FlyPy. They, at least the CrazyFly and the FlyPy ones, both have encoders on them that talk to an Arduino that send back either the attitude rate or the actual angle that the Crazy Fly or FlyPy is at. The idea of that is that you can maybe get more logging data, and you can see how closely you're tracking with your set point a little bit better. There's also an XY test stand prototype that we made this year. And the idea of that is that eventually MP4, the Computery 488 lab, should have a positional controller component. And this test stand could maybe be changed around to use the flow deck versus right now it's mainly made for the Lighthouse deck. And if you want more information about how these test stands work, especially the firmware of them, you should watch the test stand firmware video, or you should just do MP4. Okay, the custom quadcopter. The way that this works, basically it was made over the course of several years and it's really built up in the repo. It's easily the best documented part of the project. I have perused through it. It looks awesome. The idea here is that there is a custom graph control structure similar to Simulink in the firmware here that basically has like the output of one thing going into like the input of the next thing. And so there's this idea of outputs and nodes. And that kind of language has really influenced the way that the front end, back end, and quadcopter commands are all documented and spelled out. The custom quadcopter has a PID controller and an LQR controller on it, and it uses the OptiTrack system in order to fly and control its position. If you want more information about this quadcopter, you should either read the wiki or the readmes or previous senior design docs for more information. And yeah. Okay, the Crazy Fly, this is the drone that's mainly used for MP4. It's commercial off-the-shelf hardware software. In order to work with MicroCART, there's 3 types of custom set points that had to be slightly, had to be made and in order for it to work. Basically, that's the full attitude and the attitude rate. Those had to be put in. Then there's also a mixed attitude mode that we made. There's also one that Crazy Fly made. I don't know why there's 2. But if you want more information about this, you should complete MP4 because you'll learn a lot. You should watch the simulation demo video, or you should watch the Simple Swarm demo video, or you should watch the Lighthouse explanation video. Or you should consult BitCraze's documentation because there's forums and wikis and awesome documentation. Okay, the FlyPy. This is the drone that my team made. Currently, it's basically just a Crazy Fly with motors and powered by a 3S battery. It's intended to be controlled by a Raspberry Pi. That doesn't work. The idea is that we'd have 1 core running FreeRTOS, 3 cores running Ubuntu, and then the Ubuntu would be basically tricking CFlib into thinking that the Crazy Fly has an AI deck attached. The FreeRTOS core would be the Crazy Fly firmware. So we'd be pretending basically that the Raspberry Pi is a Crazy Fly. And yeah, it should support Crazy Fly expansion decks. That's mostly going to be a software thing though, because the hardware has all the pins there. But if you want more information about this, you should either watch the how to demo the FlyPy video, or you should watch the the how to use the big quad deck on the FlyPy video for more information. Next, so MP4. MP4 is the lab that we make for Computery 488. In part 1 of the labs, students tune nested PIDs for yaw, rate, or the rate and attitude of all attitudes, so yaw, pitch, roll. And then in part 2, they implement the firmware for how those controllers work. I would highly recommend that everyone on MicroCART do this. If you do it in groups, that's fine, but if you do it individually, you're going to learn way more. And yeah, it's awesome. And basically, we make this for Computery 488. The long-term idea is that the thing that should be hard about an MP4 is learning how to tune PIDs and getting the software on the Crazy Fly to work, or making sure that your software is logically sound. The hard part should not be using our software. Currently, it is using our software. And so that software should be improved. And if you want more information about how to do all this, you can read the lab doc, or you can watch the MP4 part 1 and part 2 explanation videos on the YouTube channel. The simulation, basically there's 2 types of simulations that exist currently. There's one that was made for the custom quad. They used it to test that it was behaving properly. and that they understood how everything worked. Then there's also the Crazy Fly simulation, mostly made by Jones, and rather than being fully Simulink based like the custom quad simulation, it's mostly MATLAB based, and then you just send set points and visualize stuff using Simulink. And you can do both of these either with pre-programmed set points or with a gamepad input. There is a Crazy Fly simulation open source software library that Bitcraze made, but I haven't used it. But if you want more information about this, either watch the simulation demo video or read the wiki about how to use it for more information. Then in terms of the current state of the GitLab is awesome. Has all of our code and also has wiki, tons of documentation, and a bunch of readmes everywhere. There's currently 9 branches on the GitLab. I think most of those are just for steady releases, but we're trying to cut it down as much as possible so that you only have like one branch that you can base everything else off of. And we've tried to leave things better than we found it, but you should try to do the same. And yeah, the wiki's new within the last few years, so there's a lot of older documentation that's just in READMEs or files that aren't on the wiki. So yeah, if you need to work with something really old, probably just go into the folders. And then the VM can also be found on the wiki. So the YouTube channel is more just like a living version of documentation. It should be us explaining to you how things work. And yeah, it just basically just document as many parts of the project as possible. My team has put a fair amount of effort in to try and get this better. Hopefully, there's useful information about how the different parts of the project work now, which there was not before. So yeah, hopefully that is helpful to you. And then in terms of suggestions for future teams, feel free to pause the video. You can read all this, but I'll go over the high priority items. I believe the high priority items for your team next year are getting free RTOS to work on the Raspberry Pi and getting like that with Ubuntu and getting that to fly the drone. That is probably going to take longer than you think it will. And hopefully you should be able to get that to work first semester. I think had we had a couple more weeks, we would have been able to get it to work. But it's hard to forecast exactly. But that should be a high priority item for you guys. And then also, that being said, there is a getting started with MicroCART Bootcamp. Go through that before working on anything else. But there's also, you should probably completely rework the Crazy Fly ground station and the Crazy Fly adapter to use CFlib, because I think that's going to make the ground station a lot more stable. Other than that, you can pause the video and read through the rest of these. In terms of teamwork, feel free to pause the video again, but my suggestion is mainly just go really hard first semester, work on as much stuff as possible, because you're going to need all that time second semester, because you don't understand exactly how much time things are going to take. And the other thing is you should really do MP4 as quickly as possible, because it was only really after MP4 that I'd say I understood exactly what this project was. And I didn't even do that until like the first week of second semester. I think if you guys do that early on first semester, you'll have basically an additional month or two to get things further, and that will go well with you. Other than that, that's it. This has been a really fast-paced overview video of what MicroCART is. I hope it's been helpful. And again, yeah, you should watch the rest of the YouTube channel videos if you want to know about how different stuff works. And also, we have attached our contact information onto the wiki, so feel free to contact my team as well if you have any questions. Other than that, thank you and have a great day.